Hey everyone, today we'll discuss Unit 7, Notes number 3, continuing our work on circles. And before we get into our discussion or exploration of inscribed angles, let's first review what a central angle is. If we have a circle with its center at point A and we draw in two radii, we learn that that created something called a central angle. And the measure of a central angle is equal to the measure of its intercepted arc. So central angles have a measure equal to their arcs. Well, the definition of an inscribed angle is an angle formed by two chords with its vertex on the circle. Okay, so let's take a look at a circle, and then we're going to draw in two chords, maybe a chord from point A to point B, and then a chord from point B to point C. So this angle that connects A to B and C to B is referred to as an inscribed angle. Notice that all 3 points that are mentioned, A, B, and C, are exactly on the circle. So if we were to draw another type of angle, let's just say this angle, and the vertex right there, right here would be the vertex. This particular angle is not inscribed. In order for it to be inscribed, the vertex has to be on the circle. All right, there are a series of theorems that will lead to problems that we can solve. Our first theorem says the measure of an inscribed angle, so how many degrees are in an inscribed angle, is equal to half the measure of its intercepted arc. So if you trace out the sides of an inscribed angle, the intercepted arc is the arc that it cuts off on the circle. So we could say in this particular example that the measure of angle C is equal to 1/2 the measure of arc AB. Well, we have to figure out the measure of arc AB. If you take another look, notice that we've got this 80-degree angle measure right here, and that's a central angle. And remember that the measure of a central angle is equal to its intercepted arc. So that arc, AB, is actually 80 degrees. So now we can use that to find the measure of angle C. Measure of angle C would be half of 80. Therefore, the measure of angle C is 40 degrees. Our next theorem states that if two inscribed angles of a circle intercept the same arc, then the angles are congruent. So if I draw two inscribed angles, and I'm going to call this angle 1, and I'm going to draw a second one so that its endpoints end up in the same position. Both of these angles intercept the same arc. So I'm highlighting the arc in gray for angle 1, and now I'm going to highlight it in red for angle 2. Alright, and you see that both angles intercept the same arc, so the measure of angle 1 must be equal to the measure of angle 2. Again, because both are inscribed angles that intercept the same arc. Let's just say, for instance, that this arc is AB and it has a measure of 60 degrees. Well, then we can say the measure of angle 1 equals 1/2 of its intercepted arc, or half of 60, which is 30, or the measure of angle 2 would be equal to half of 60, which is 30. So in another quick example, if I have a circle and I have this arc that's, say, 20 degrees, so that angle is 20 degrees, and I have another angle that intercepts that same arc, I would know right away that that angle measure has to be 20 because both of those inscribed angles cut off the same arc. And by the way, that arc would be 40 degrees because the angle is half of the arc. So half of 40 is 20. All right, another theorem says if a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. So check this out with me. This segment right here is a diameter because it goes right through the center. Remember that a diameter intercepts a semicircle. You guys know how many degrees are in a semicircle. 180. Sorry, I didn't switch to the pen tool there. 180. This angle intercepts that arc of 180 degrees. Therefore, it has to be 90 because 90 is 1/2 of 180. All right, this next theorem says the opposite angles of a quadrilateral inscribed in a circle are supplementary. So quadrilateral has 4 sides. So let's draw a quadrilateral so that the 4 vertices or corners end up on the circle. Now it's looking kind of like a rectangle or a square, but it's not exactly. We don't know that for sure. What we can say for sure is that these opposite angles are going to be supplementary, meaning they add to 180 degrees. So they get all those vertices on there. So opposite angles would be like angle A right here and angle C. So we could say for sure the measure of angle A plus the measure of angle C equals 180. Likewise, we could say that the measure of angle D and the measure of angle B is also equal to 180. Again, opposite angles of a quadrilateral are supplementary, not congruent, so just be careful with that. So they're going to add to 180. All right, next let's check out how we can use all of these theorems to set up and solve equations. All right, in the first case, it says find the indicated measure in circle P. So this is the symbol for circle. All right, we first want to find the measure of arc EG, so I'm just going to highlight that. This is arc EG, so I go to the endpoints and I want to see if I can figure out where the angle is that intercepts that arc. So I follow, like from those 2 endpoints along these line segments until I find the angle. And it turns out that that angle measures 50 degrees. So to get from the angle to the arc, we double it. We do 2 times 50, which is 100. So we would say that the measure of arc EG is 100 degrees. So again, the measure of an inscribed angle is half the intercepted arc. So if you know the angle, you're going to multiply it by 2. So 2 times 50 is 100. All right, I want to point out that this line segment going from F through P to G is a diameter. So we have a semicircle. So since this arc is 100 degrees, this arc from F to E will have to be 80 degrees. Okay, just in case that comes up. All right, the next piece, in part B, we want to find the measure of angle G. So I already have one side of angle G highlighted in green, so I'm going to highlight the other side. If you trace the sides of the angle out to the circle, you want to notice the intercepted arc, and this arc is 48 degrees. So in order to find the measure of angle G, we're going to take half of that. And half of 48 is 24 degrees. So the angle equals 1/2 the arc. All right, so the measure of angle G is equal to 1/2 of 48, which is how I arrived at 24 degrees. Again, the measure of the arc equals 2 times the measure of the inscribed angle. All right, let's check out what's next. All right, angle, and number 2, it says find the measure of angle JLM. So I'm going to use my highlighter tool and highlight angle JLM. So go from J to L and L to M. So that's this angle right here. What I noticed about angle JLM is it intercepts the arc from J to M. And then I notice that there's another angle that also intercepts that same arc, and that would be angle K right here. If I follow the sides of angle K out to the circle, it intercepts the same arc. Now you could take this angle measure 55 and double it to find the angle of 110, and then take half of that to find angle L. But it's much quicker to use our theorem, which says if two inscribed angles intercept the same arc, then they have to be congruent to each other. So the measure of angle JLM is 55 degrees. So you don't necessarily have to find the measure of the arc as an intermediate step, but it's okay if you want to. All right, in number 3, we're going to apply the theorem that says the opposite angles of a quadrilateral inscribed inside of a circle are supplementary. The problem is we have a couple of question marks here and here that we have to fill in. Okay, so I'm going to take care of those two first and clean that up just a little bit. Okay, and to do that, I want to take a little bit of help from my picture. All right, first, I'm going to solve for the measure of angle P. So the measure of angle P, I'm going to try to keep this all in red. The measure of angle P is equal to 1/2 its intercepted arc. And if I trace out the sides with my highlighter, angle P stretches out to point O and point Q. So angle P actually intercepts this whole arc. So it goes through 130 degrees plus 54 more degrees. So we can say the measure of angle P equals 1/2 of the sum of 54 plus 130, or the measure of angle P equals 1/2 of 184 degrees, So in other words, the measure of angle P is equal to 92 degrees. All right, that 92 degrees will come right in here. Okay, next, we now have a pair of opposite angles in this quadrilateral. So these two angles have to add up to 180 degrees. So we're using our the quadrilateral theorem. So opposite angles of a quadrilateral inscribed inside of a circle are supplementary. So 4y plus 92 equals 180. 4y would then be equal to 88. And then take and divide by 4. And we end up with y is equal to 22. So let me catch up with what I've said. Again, we know that opposite angles of a quadrilateral inscribed inside of a circle are supplementary. So I'm kind of abbreviating it, but so that's how I knew to set up that equation. Okay, we have to also solve for x. So if you notice, x is right here in that 3x, and its opposite, this angle, which is unknown. So we're going to use the same logic that we did before. We're going to extend the sides, all right, and take a look at the arc that angle cuts off. It's 130 degrees plus 110. So we'll say the measure of angle Q is equal to 1/2 of 130 plus 110, which would be 1/2 of 240, which is 120 degrees. Okay, again, we're using our theorem that says the opposite angles of a quadrilateral inscribed inside of a circle are supplementary. So now we can set up the equation 3x plus 120 equals 180. Take and subtract 120 from both sides, and we end up with 3x on the left and 60 on the right, and then divide by 3, and we get x is equal to 20. Okay, and that's the final answer. Good luck on the homework. As always, please see me for extra help if needed.